Hello, this is A.K.M. Abdullah Amin, Elizabeth Creek Fellow at Harper Adams University in the United Kingdom and Assistant Professor at Bangladesh Agricultural University in Bangladesh. Me, together with Professor James Luenvak Deboe, who is the President of the International Society of Precision Agriculture, and Elizabeth Creek Professor at Harper Adams University, Kit Franklin, Principal Investigator of the Hands-Free Farm Projects, and Senior Lecturer at Harper Adams University, Elizabeth Creek Professor of Harper, Professor Carl Vahendet, have been doing research on the economic implications of field size for autonomous arable crop equipment. As we know that post-war agricultural intensification entails biodiversity loss in the Great Britain, and the United Kingdom continually adopting larger equipments and field size for labor productivity. On the contrary, the environmental management studies favored small fields for increasing biodiversity. In this backdrop, autonomous crop robotics are hypothesized as the pathway of sustainable intensification solution that will facilitate fourth agricultural revolution and revolutionize the precision agriculture. However, the existing studies on autonomous crop robotics mainly focused on the cost-saving potentials. Nevertheless, nothing is known on the economic implications of field sizes and shapes. A recent study by Loenvak de Boer and his colleagues, published in 2021, hypothesized that autonomous equipment will diminish the pressure of field enlargement. However, due to the data deficiency of field times and field efficiency, they were unable to test the hypothesis. To shed light in this research gap, the objective of the present study was to assess how field shape and sizes impact the economic viability of autonomous equipment in commodity crop production. The study hypothesized that autonomous equipment would make it possible to farm small fields profitably. Here is the picture of the hands-free farm operations. The study used the experience of the hands-free hectare demonstration projects, and the short video shows the hands-free farm operation including drilling, spraying, and harvesting operations. This present study developed algorithms for calculating field times and field efficiency, and the data of commodity production and cost were collected from the hands-free hectare operations, agribusiness consultant, and Nick's pocketbook. Land constraints data were collected from Department of Environment, Food and Rural Affairs, and the machine specifications data were collected from the experience of the hands-free hectare, John Dree, and the published paper of Arsalan and his colleagues. The results of the study showed that field efficiency differed substantially between 1 hectare and 10 hectare fields, which is evident in the right side bar diagram. But for a given equipment set, the field efficiency were almost the same for 10 hectare to 100 hectares, which is visible here. And the hands-free hectare equipment had comparatively higher field efficiency, whereas the medium 150 and large 296 horsepower equipment sets were not efficient for the small fields. The interesting finding of the study is that farming with autonomous crop robotics had similar cost of production, irrespective of field size. The line graph shows that the lower section of the line graph, we found that there is comparatively flatter L-shaped cost curves. Even if the 1 hectare small fields is operated with a small 38 horsepower conventional equipment set, the production cost was higher, which is shown in the L-shaped cost curve for 38 horsepower equipment set. Field crop robots had a cost advantage over conventional systems as the conventional systems incurred higher wheat production cost, which is by 30 to 40 pound per ton, which is evident here. Considering the trade-offs between conventional agricultural mechanization with human operator and biodiversity loss, the study reached in the following conclusions. Field sizes have a substantial impact on the technical and economic feasibility of conventional systems, whereas crop robots were able to farm small fields profitably. Irrespective of field sizes, autonomous crop robots had lower cost of production compared to conventional machines. Autonomous crop robots diminish the pressure of field enlargement, which will encourage environmental land management schemes in the United Kingdom and agri-environment schemes in the European Union and elsewhere. Autonomous crop robots will encourage biodiversity. The picture reveals that biodiversity are encouraged through hedgerows, infill trees. For further details, please visit our published proceedings paper. Thanks for your patience hearing.